Good morning, my fellow students, my mommies, my daddies, my junior ones, and my senior ones, my colleague in school. I say good morning to you all, and welcome to my page. This morning we'll be taking a partial fraction, and before we start this topic, I'm pleading to every one of us here, please and please like my page. I need your comments, your observation. I want you to like the page, and I want you to help me to share the page all through your social media and to the groups as well. So back to this partial fraction. Let me just give you the hint so that you'll be able to get this topic very, very well on the long run while we solve. So when you're solving a partial fraction, the first thing you need to know under this topic is that you need to know how to factorize very well. So because this topic, while solving some questions on this topic, I'll be using a factorization method to factorize out some terms. So please, you have to understand a factorization very well. You have to know how to factorize very well. So let's go back to this partial fraction. Before we start this partial fraction has many rules. So, and I would like to give us the two rules this morning. So we look at some questions that involve these rules, then we sort them out. So the first rule of this topic is this. The first rule says if the degree of numerator is higher or equal to the degree of denominator, it is possible to carry out a division to obtain its quotient with a fraction whose numerator is of lower degree than the denominator. Now, let me explain what they are trying to tell us there under this first rule. What they are trying to tell us there is that if the power of the numerator is higher than the power of the denominator, we are to what? We are to resolve into what? And we want to resolve the question into partial fraction. We need to what? First carry out a division before we resolve it into partial fraction. But the rules also says if the power of the numerator is equal to the power of the denominator, that is, if both the power of the numerator and the power of the denominator, if they are equal, that if they are the same, that is, we are to carry out the division first before we move to what? Solving into what? The partial fraction. That is what the first rule says there. So let's go to the second rule before we solve a question. The second rule says, so each linear factor of the form x minus a in the denominator, there corresponds a partial fraction of the form a over x minus a, where a is constant. Now, for this now, to each linear factor, if you look at the linear factor we have here is of the form x minus a. That is, you understand what we talk about linear equation from the word linear equation. So when you see something linear, that is, we have something linear here of linear factor of the form x minus a in the denominator. That is, this form is usually found in the denominator. So it corresponds to what? A partial fraction of the form a over what? X minus a. This capital A you are seeing here is a what? Is a constant term in partial fraction. So this is how the partial fraction form of this linear factor will looks like, where this a is constant. So this first rule and the second rule, they work along with each other. So let's take a question here to buttress our point. The question is this: resolve into partial fraction. Resolve into partial fraction. We are to resolve x raised to power 3 plus x raised to power 2 plus 4x divides x raised to power 2 plus x minus 2. And like I said earlier, that if you want to understand this topic very well, you need to know how to factorize. So let's solve this question now. Now, solving this question now, if you look at this, what we have on the numerator, we have x raised to power 3 plus x raised to power 2 plus 4x divides in the numerator, while we have x raised to power 2 plus x minus 2 in the denominator. If you look at the power of numerator and the power of denominator, if you look at the both power now, you see that the power of what? Numerator is higher than the power of what? Denominator. So, and by the rules of the first rule, which says that if the power of the numerator is higher than the power of the denominator, what are we going to do? We use what? A division method first before we resolve it into partial fraction. That is, we divide the denominator by the numerator, and that's why we have it here. By division method here, look at this now. The numerator is the denominator. The numerator is what we have inside, while the denominator is what we have outside as a normal division. So you divide this by this now. Let's take a look now. If you divide x raised to power 2 divides x raised to power 3, what we have left? We have what? X left. So having x left now, you multiply this x by this x raised to power 2 again to give us what? X raised to power 3 here again. So you multiply this x by x again, you have what? X raised to power 2. And you multiply x by minus 2 here, you have what? Minus 2x. So by equating the both now, if you look at this now, so you need to take a what? You need to take a subtraction of x raised to power 3 plus x raised to power 2 minus 2x from x raised to power 3 plus x raised to power 2 plus 4x. You need to take the difference of both. That's why we have a minus here. So if you subtract this from this now, x raised to power 3 minus x raised to power 3 will go because they are both same. So it will go. X raised to power 2 minus x raised to power 2 will go as well. So we have a minus sign here and we have a minus sign here. Minus times minus gives us what? Plus. So 4x plus 2x gives us what? 6x. Hope you understand what we are saying here. So in this case now, we move further. From this now, I've gotten my what? My quotient, my remainder, and my divisor. So that's why I go back to a formula called Q plus R over D. That is quotient plus remainder divided by divisor. So, and I've stated it here that where x, our Q is the x, our R is the 6x, and our divisor is x squared plus x minus 2. So in this case now, from this formula, we go by this. So from this formula, we go by this. So from there now, like I said in the very first case, where we're given the second rule that to each linear factor of the form x minus a in the denominator, there corresponds a partial fraction of the form a over x minus a, where a is constant. So look at what we have here again. If you look at this now, I've separated 6x over x plus x squared plus x minus 2. I've separated it. Some of us will be confused that why am I not having x here at the solution here? The reason why I'm not having this quotient here of x as the solution here is because I don't need a quotient to solve the question. What I need is my what? My remainder and my divisor, and that's why I'm having 6x over x plus 2 plus x minus 2. So in this case now, I will have to factorize x squared plus x minus 2, and that's why I have it at the back here, that x squared plus x minus 2, if you factorize it out, you have something of this to be your final answer, which is what? X minus 1 x plus 2 as your final answer after you have factorized it out. So in this case now, you move again, you come back here because of this form where you have in the second rule. So you move back here again. So you've changed this x squared plus x minus 2, you've changed it into the form of what? X minus 1 x plus 2. Now, since we are not having a single constant, we are only having this x minus 1 now. So it will just be a over x minus 1. But now we are having two values for x. So that means that what? Our constant will be what? 2. So that's why we have what? A over x minus 1 plus b over x minus 2. Now, from here now, we go again. You find the LCM. LCM of x squared plus x minus 2. If you look at this now, the LCM of x squared plus x minus 2 will give us x minus 1 x plus 2. And like I said earlier, that we are going to neglect this brother x here now. If you neglect this x here, meaning that what? You have only this one left here. So if you divide x squared plus x minus 2, if you divide it by x squared plus x minus 2, it will give us what? 1. So 1 times 6x will give us what? 6x, and that's why we have it here. So if you divide again the LCM of x minus 1 x plus 2, if you divide it by x minus 1, you have your answer to be what? X plus 2. So you multiply x plus 2 multiply by a, you have this result here. The same thing applies to x minus 1 x plus 2. You divide it by what? X plus 2. You have x minus 1 to be the answer. So you multiply that x minus 1 by b here, you have this one here. So now I want to get each value for a and b. And for this now, I have to eliminate either a or b first. To eliminate now, let me eliminate b first. By eliminating b first, so I have to find a means of taking what can I do to make this b become 0. And that's why I said taking x equals to what? 1. If you take x equals to 1, that means whenever you see x here, you put what? 1 there. So that means we have what? 6 into bracket of 1 equals what? A into bracket of 1 plus 2 plus b into bracket of 1 minus 1.